students, good morning, and here we are with a physics lecture in which we are doing mathematical methods as your next chapter in the syllabus, and in that we are studying the vector analysis. Already in the last lecture, students, we have seen what are scalar quantities and what are vector quantities. We have seen the difference between a scalar quantity and a vector quantity. Now today we are going to continue with our study with the vectors and the vector analysis. So here is a part that is going to be a sort of revision for you. So it's a warming up time for you now. So here we have the definition of the vector revised again. So what is a vector? It is a physical quantity which can be completely expressed by magnitude and direction. So for vector, for its complete expression, magnitude plus the direction in which the change in the magnitude or the direction in which that vector is advancing becomes very, very necessary. So a vector quantity will be completely expressed only when we supplement direction along with the magnitude of that vector. Okay? How do you represent a vector then? Say we have to represent a displacement vector between 2 points P and Q. How am I going to denote this? We are going to denote it by tan arrowhead as PQ. Over it I am going to put this arrowhead. Okay? And I will be reading this as vector PQ. How am I going to read it? Vector PQ. Okay, अब ये vector PQ है, मतलब it is the vector. Say if it is a displacement vector, then it is the displacement vector which is advancing from the point P and moving towards the point Q. Okay, so P is the tail of the vector and Q is the head of the vector. Are you getting it? If it is to be expressed in a single lettered form, then I can express vectors as single vectors or single lettered vectors as vector A, vector X and so on. Okay? Now, this is the representation of a vector which has magnitude and the direction. Then how do I give the magnitude of a vector? For representing magnitude of a vector, I put that vector in this modulus sign. What is this sign? Modulus sign. So when I write any vector in this format, what am I expressing, students? We are giving the magnitude of that vector. So if I have a vector written in this format, how am I going to read it? I am going to read it as magnitude of vector A. Say for example, you have to express displacement vector X in terms of its magnitude. Then I will write this as displacement of vector X, the magnitude of displacement of vector X. Say that vector I am representing as vector X. So magnitude of displacement of vector X can be equal to how many kilometers? Say 5 kilometers, 1 kilometer, 1 centimeter, 1 millimeter, whatever it is. But this gives only the magnitude. Are you getting it, students? Okay. So this becomes very important for you to understand the vector analysis. And vector quantities are going to be very important and should be well understood, because as we advanced in our physics, we are going to express the physical quantities either as a vector quantity or as a scalar quantity. And when it is a vector quantity, it always will have direction along with the magnitude. So that directional aspect of vector quantities should be well understood by you. Are you getting it, betos? Right. Now we will continue with our further part in vectors. Now, with this knowledge of vectors, we will continue with the study of vectors, in which we are going to study the types of vectors. What are we going to study now? The different types of vectors. Now, what are the different types of vectors? The first type of vector is the zero vector. What is it? Zero vector, or it is called as the null vector. What is the first type? Zero vector or the null vector. Okay, now let us try and understand what is this zero vector or null vector. Now zero vector or null vector is a vector whose magnitude is equal to 0. जिस वेक्टर का मैग्नीट्यूड 0 हो वो वेक्टर हो जाएगा नल वेक्टर. Every null vector is represented as vector O. Okay, that means it is the vector which is a zero vector and has magnitude equal to 0. So what is a zero vector? A vector whose magnitude is 0. Is 0 or null vector. Okay, how do we represent it? Representation. This is the representation. So I am going to read it as zero vector or null vector. Okay, now what are the examples of this zero vector or null vector? Let us see. अब आप बोलोगे कि ऐसे कैसे हो सकता है कि वेक्टर का मैग्नीट्यूड 0 हो, तो हम एग्जांपल्स लेंगे which will make you understand how can there be physical quantities whose magnitudes are 0, though these are directional aspects. Okay, so let us take some examples of zero vector. First example is velocity of stationary particle. Velocity of a stationary particle. Velocity of a stationary particle means what? Say for example, you consider a particle A. Okay, this is a particle A. Okay, now this particle A is stationary. Stationary means it is not moving. When it is not moving, what will be its speed? Obviously equal to 0. Yes, speed is a scalar quantity. What will be its velocity, which is a vector quantity? Velocity, magnitude of the velocity is always the speed. वेलोसिटी का जो मैग्नीट्यूड होता है वो स्पीड होता है, तो मैग्नीट्यूड कितना हो गया? 0 हो गया. डायरेक्शन कुछ भी हो सकती है. द पार्टिकल कैन बी हेडेड इन दिस एनी ऑफ द डायरेक्शन. Getting it? Now this particle which doesn't have any velocity right now, the magnitude of the velocity is how much? 0, as this is a stationary particle. This becomes a zero vector. Okay, getting it? So velocity of a stationary particle is a zero vector. Now if you take the second example, acceleration of a body moving with uniform velocity. Okay, अब acceleration क्या होता है? What is acceleration? Acceleration is the change in the velocity. Like, say for example, you are on your bike and you are moving at a speed of 50 kilometers per hour. This is your velocity. You are going northwards. Okay, तो velocity आपकी क्या हो जाएगी? 50 kilometers per hour northwards. This is going to be the velocity of your bike. You keep on moving northwards. Direction आप change नहीं कर रहे, आप northwards ही जा रहे हैं. और कॉन्स्टेंटली आप अपनी बाइक की वेलोसिटी 50 किलोमीटर पर आवर रख रहे हैं, तो हम आपका ट्रैक ओके एनालाइज करेंगे. फर्स्टली से यू वर एट दिस पॉइंट P, you started and the velocity of your bike over here at this point, how much is it? 50 kilometers per hour. Then you have come to this point Q after 1 hour. Again your bike has the same velocity, 50 kilometers per hour from this point. You are moving to this point up after 1 hour. And you keep on moving with the velocity 50 kilometers per hour. Now if I want to calculate the acceleration, acceleration is what? Vector A is acceleration. Okay, this is acceleration vector. How do I give this acceleration vector? It is initial velocity, that means vector U minus final velocity vector V minus initial velocity vector U upon the time taken for this change. Now what is your velocity? Magnitude of your velocity? Initial velocity 50 kilometers per hour. This is your final velocity. What is the magnitude of your initial velocity? Again 50 kilometers per hour. Okay. Upon the time, how much is the time you are taking to change, go from point P to point Q? 1 hour. So it is 1 hour over here. So what do you get? 50 minus 50, कितना हो जाता है? 0. So what is the magnitude? R and this will get cancelled. So magnitude of acceleration is 0 kilometer. This becomes raised to minus 2. So acceleration of your bike which is moving in the same direction with constant velocity becomes 0. So here we have this acceleration as a 0 vector. Okay, so what is a 0 vector? A 0 vector is a vector whose magnitude is 0. Okay, it can be in any direction. But the vector whose magnitude is 0 will be called as the 0 vector, or it is also termed as the null vector. Are you getting it, students? You need to take down this, you need to take down the examples. It is very, very important. Definitely you will be asked these definitions or examples in your examination. Okay, it's not only from the point of view of examination, but the references regarding all these types of vectors are going to be in your physics syllabus from right on till you complete your studies. So that is going to be an integrated part of physics. So you should know everything about the vectors. Have you got this? This is regarding the 0 vector. Now let us go to the next type of vector. And that next type of vector is the resultant vector. What are we going to study now? The resultant vector. Okay, let us understand what we mean by resultant vector. Now, if we go for the definition of the resultant vector, we define a resultant vector as, how do you define the resultant vector? We define it as the resultant of two or more vectors is a single vector which produces the same effect, as these vectors. Okay. So what is resultant vector? Resultant vector or resultant of two or more vectors is a single vector which will produce the same effect as would be produced by those vectors. Okay. अब एग्जाम्पल लेंगे हम. देखो, we'll consider a point A and we'll consider a displacement vector. Say an object is getting displaced from point A to point B in this direction. Okay, then let me represent this as vector AB in this direction. Okay, and now this particle, this object has come to this point B. From point B, it changes its direction and moves in this direction towards the point C. So now the particle is here or the object is here at this point C. Let me denote this as vector BC. C पे आके ये particle डायरेक्शन बदल देता है और ये डायरेक्शन में चला जाता है. Let us take this as point D. Okay, and this as vector CD. This is the displacement of the particle. Firstly, it has taken this direction and moved from A to B. I am representing this displacement as vector AB. Then it changes its direction and moves from point B to point C in this direction. I am representing this displacement as vector BC. C पे आके फिर से उसने डायरेक्शन चेंज कर ली और मूव हो गया पॉइंट D के तरफ. इस डिस्प्लेसमेंट को हम रिप्रेजेंट कर रहे हैं वेक्टर CD से. ओके, तो ये पार्टिकल का डिस्प्लेसमेंट हमने 3 वेक्टर्स में रिप्रेजेंट किया है. वी आर रिप्रेजेंटिंग द डिस्प्लेसमेंट ऑफ दिस पार्टिकल्स इन दिस 3 वेक्टर्स. So initial position of the particle was at A and final position of the particle was at D. Okay, इसका मतलब पार्टिकल कहां से कहां डिस्प्लेस हो गया है. इन एक्चुअल इट हैज गॉट डिस्प्लेस फ्रॉम द पॉइंट A टू द पॉइंट D. कहां से कहां डिस्प्लेस हो गया है? फ्रॉम द पॉइंट A टू द पॉइंट D वाया दीज पॉइंट्स. दीज आर वाया पॉइंट्स. अब ये एलिमिनेट कर लेंगे और यदि ये पार्टिकल डायरेक्टली A से D को डिस्प्लेस हो रहा है ऐसे ये डायरेक्शन में, तो इट इज गोइंग टू प्रोड्यूस द सेम इफेक्ट ना. तो ये 3 वेक्टर्स जो इफेक्ट प्रोड्यूस कर रहे हैं वो सेम इफेक्ट ये वेक्टर AD प्रोड्यूस कर रहा है या नहीं? ऑब्वियसली इट इज प्रोड्यूसिंग द सेम इफेक्ट. सो दिस सिंगल वेक्टर becomes the resultant vector. What does it become? The resultant vector. Because if I add vector AB and then vector BC and then vector CD in their magnitudes, what am I getting? I am getting the resultant vector which is equal to vector AB. Am I getting it or not? Okay, so this vector AD becomes the resultant of these 3 vectors. Resultant of what? These 3 vectors. Are you getting it, everyone? Okay, so resultant vector is the resultant of 2 or more vectors. Resultant of 2 or more vectors becomes a single vector which will produce the same effect as produced by those vectors. Are you getting it? Okay, and here is the example of the resultant vector. Again, this is an important vector type. You should know the definition, you should know what is the resultant vector, and in your physics derivations, in most of the derivations we go on referring to this resultant vector, resultant vector, resultant vector whenever we are dealing with vector analysis of any physical quantity. Are you getting it? Okay, so be clear with it, understand it well. Okay, that is very, very important. So we have dealt with 2 types of vectors, zero vector and resultant vector.